So here we're told that a darts team is going to play a match on Saturday and on Sunday, and we're told that the probability that the team will win on Saturday is 0.45. We're then told if they win on Saturday, then the probability that they will win on Sunday is 0.67. And then if they do not win on Saturday, then the probability that they will win on Sunday is 0.35. And we're asked to use this information to complete the probability tree diagram that we have below. So I'm just going to start by making sense of this diagram. So here we have Saturday, so this part of the tree diagram is representing Saturday, and the two options are they'll either win or not win. And these are the exhaustive set of outcomes. They will either win or not win. There's not a third option, so the probabilities of these are going to have to sum to 1, because it's certain that they will either win or not win. We then have the same for Sunday, however, this branch of the tree diagram is dependent on them winning on Saturday, and then this one here is dependent on them not winning on Saturday. So if we have a look, firstly, we need to fill in all of the gaps, and we can start here with the probability that they won't win on Saturday. Because we know that the probabilities here must sum to 1, we can simply do 1 minus 0.45, and that gets an answer of 0.55. So these probabilities of winning and not winning on Saturday now sum to 1. Now I need to look back in the question at the information, and we're told that if they win on Saturday, so they win on Saturday, so we're looking at this branch of the tree diagram now, the probability that they will win again on Sunday, so on Sunday that they will win having won on Saturday, is 0.67. So I can fill that in this box here. And then similarly again, the probability of them either winning or not winning after having won on Saturday, these two probabilities in this section have to sum to 1, again, because those are the only two outcomes that can happen on Sunday. So 1 minus 0.67 is going to give us an answer here of 0.33. And then finally we can fill in the last gaps. So if they do not win on Saturday, so they don't win, so we're looking at this part of the tree diagram, then the probability that they will win on Sunday is 0.35. So the probability that they will not win is 1 minus 0.35. So that gives us an answer of 0.65. Now we would gain the first mark here for getting this probability of 0.55 in the correct place, and then the second mark is going to be for a fully correct labelled tree diagram. So here I'm asked to find the probability that the team will win exactly one of the two matches. So if I have a look at the tree diagram, there are two ways of this happening. So they have to win exactly one, so they could either win on Saturday and then lose, not win on Sunday, and they've won one match. Or alternatively, if they didn't win on Saturday, they could then go on to win on Sunday and win exactly one match in total. So now I need to find the probability of these two events occurring, and then I can add them together to find the total probability that they'll win exactly one match. So if I want to work out the probability that they win on Saturday and don't win on Sunday, we're working horizontally across the tree diagram. And when we're working like that, we're going to multiply the probabilities together. So here, if we have the probability that they win on Saturday, which is 0.45, we can multiply that by the probability that they don't win on Sunday, so 0.33, to get the probability of them winning on Saturday and not winning on Sunday. And that gives me an answer of 0.1485. And then similarly, I can do the same below. So when they don't win on Saturday, 0.55. And we'll multiply that by the probability that they do win on Sunday, so 0.35. And that's going to give me an answer of 0.1925. Now in order to find the total probability for them winning exactly one match, We're now working downwards down the tree diagram again in a way, so we can simply add these two probabilities together to find this total probability. And that gives us an answer of 0.341. And that is going to be the correct final answer for this question. Now, as for how the marks are awarded, we'd have gained our first mark for firstly finding one of these values, so doing this multiplication here. And then a second mark would be for following through with the method and basically adding together the two probabilities. And then the final mark is for the correct final answer that we have here.